Yeah, hi everyone. Good evening. Am I audible?
Yes, sir. Good evening, sir.
Okay. Okay. So today is also the session. So we just planning to discuss the basics of the programming, how we can understand the programming before writing the actual code. So today we will discuss some basic idea of the programming and algorithms and flowchart and pseudocode. I think you have listened these terms. So we will discuss these things. So before starting the session, so if anyone have any query,
Sir, I have a doubt. Where can we view the live sessions if I have
uh,
missed, if I have
huh.
missed the session?
So where from you got this link, invitation link, this meeting link?
WhatsApp.
WhatsApp.
Yes, sir.
Okay, so there is one calendar actually in the portal. You can add the correct. So let me share where you can find actual. I hope my screen is visible.
Yes,
Yes,
sir.
Okay, so this is the portal view. Okay, which you are doing the assignments, all the things. So here the course inside the course introduction, just go to the general instruction and important links. Okay, and after that, some link will be appear. It is taking some time. Just yeah. So calendar for this course. Okay, the first link. Okay, so you can click on this link and the course calendar will be added in your calendar. So now when you open the calendar.google.com, so this calendar will be added where you can see the schedule of the live sessions. Inside the live session, when you click on the schedule, you can see the link is given, and also YouTube link is also given.
All
Okay.
the sessions are uploaded on YouTube, sir.
Yes, all the sessions are uploaded. Previous two sessions are have also uploaded on the YouTube.
Okay, sir.
Okay. Okay, so just go, or you can after once click on the YouTube link, you can subscribe the channel. Then you can just directly visit the all your videos. Okay, or you can note down if you don't want to subscribe, then you can note down the channel's name. Okay, so
sir. All of the sessions in Monday week are collapsed, sir, with English also. So can you please change the day time?
so today we have changed the
No, for another 3 days also.
initial timing was 6 to 8 for today's session, but we have changed this to 7 to 9.
Yes,
Okay,
sir. For
so
another 3 days also, it was same as a previous, sir. Like 6 o'clock it starts.
no, but our C programming sessions are 8 to 10 on Friday and 3 to 5 on Saturday. So I think it is not clashing with the English. Okay, so timing is not same for all the days.
Excuse me, sir.
Yes, Naman.
Sir, in graded assignment 1, I am not understanding the 10th question, 6th step, how to execute that.
Which one? Week 2 or week 1?
Week 1 graded assignment 1.
Okay, 1 second. This one?
Yes, sir. 6th step, I am not understanding how to execute.
Sixth step.
Yes, sir.
Huh. So simply you here you are multiplying 2 into what is the value inside the R0. This is simple multiplication of 2 and R0 value. And
But,
after that, you are assigning that value into R3 place.
sir, according to question, we have options. So I already assigned the R3 value to be R2 plus R3. I am doing like that. So how to?
here one sequence of instruction is given. Okay, and how you can solve this problem? Simply just take one option and insert at this at step 5. Okay, and after that just start the execution one by one from the top, 1 2 3, in that way, and just follow this. First assign the value of m0 to inside the r0. Okay, then assign m1 value into r1, then assign value r0 multiply r0. Okay, so this is r0 square, and do this operation and assign the value inside r2. So just follow the instruction and execute all the instruction one by one, and check what value is coming in this location, m2 location last. Okay, so this value is coming correct according to the our problem statement or not. So just for to verify this, just take some value for a and b. So like you can just take 3 and 4, a equal to 3 and b equal to 4, and directly solve this equation. What answer you are getting when you are taking a equal to 3 and b equal to 4. Okay, so the same answer is coming when you are following this sequence of steps in m2 or not. Okay, so just put these option at the place of step number 5 and check what output is, what value is coming at the 9th step inside the m2. Okay, if the value is not correct according to the equation, then change the option b, select the b option and just put here step number 5, and then perform the process again.
Okay, sir.
Okay, in that way just follow the step by step operation and just check, verify the answer.
Sir,
Yeah, so today we will discuss some similar things, algorithms.
sir, I have it.
Okay, yeah, who is this? Let
Sir.
me just call one by one. Yeah, what's your name?
Alia.
Yeah, Alia, go ahead.
Sir, then the 6th question of the graded assignment 1.
And did you join the previous session?
Yes, sir.
6th question, I think we have discussed the 6th.
No, I just
six-
have it.
Okay.
Sir, in the second option, we are overwriting the value of R2 in the 4th step. 5th step.
So
Will
if
the program
yeah, if anything wrong is happening in this sequence, so that means this output should not be correct. This code should not be correct.
No, sir. Initially we assign the value of m of 1 to r of 2, and in the second last step we are overwriting the value of r of 2 to r of 3 plus r of 2. Is that
First, one second. You are talking about second option.
yes, sir.
Some noise is coming earlier. So okay, what you are saying? Where we are changing the value?
Initially we put the value of m of 1 to r of 2.
M0 inside R1, M1 inside R2. Okay.
Yeah, and in the second last step we are assigning the value of r of 3 plus r of 2 to r of 2. So we are overwriting the value. Will the program work right?
So what is this we are asking that? We are asking that we have one equation 4 into a plus b. Okay. And the value of a and b are stored inside m0 location and m1 location. So that value can be anything for the a and b. Okay. And now just check that if you are following this sequence of steps which are given in the options, so are you getting correct answer in m2 location or not? If you are not getting correct answer, that means that sequence of code is not correct.
Okay, sir, but I am just asking whether overwriting values like
Overriding is possible. What we are
Okay.
doing, we are using this assignment operator. Okay, so we are during the process we can change the value of any location, any variable. Okay, so any this registers. So here we are using registers, so we can update the registers value according to our algorithms or sequence of steps. What logic we are using, according to that we can change the values in the process.
Sir, after we update that value, the previous value get discarded?
Yes. Okay, so if we are assigning any other value, so previous value will
If
lost.
we are if we are doing some new operations to that register, then the previous operations, the register pairing will be deleted or started.
Operation means assigning something. If we are assigning something new, so previous value will update it. Okay, so that register can contain only one value. If we are assigning something new in the process, so that value will be updated.
So that was only my doubt. Now understood.
Okay, so here assignment, this assignment means when we are writing this r0 equal to r4, so that means which value, so value on the right side of equal sign. Okay, so that is actually value, and what are the things on the left side of the equal sign, that is actually a location. So we are assigning the value from the right side on the location on the left side. Okay, so this is the meaning of this equal sign. Okay, if we are writing m2 equal to r2 like this, so that means the what value is stored in the r2, that value is assigned on the location of this left side location m2.
Sir, I have another.
Yes, Alia, go ahead.
Sir, how do we determine the speed of memory? Like in the
How,
fourth question,
how we determine the memory
memory speed of the memory, like RAM and
speed?
yes, sir. Like which is the fastest and how do we determine?
Okay, so why you are require the speed? Why this question comes in your mind?
And there was a question, like fourth question, and I don't know how do we determine the speed of the memory?
No, speed. If you are talking about the speed of the memory, so this is not the relevant question actually. Memory speed is dependent on the hardware, what type of material we are using in the memory. So as we have discussed the memory in the big one, so registers are faster. Some material are different actually for the registers. Some semiconductor things are used, and so that because of that that are closer to the processor, so because of that we generally say that register speed is fast for the processor. Similar when we comes on the next level, when cache memory comes, then RAM comes, then hard this secondary memory comes. So inside the secondary memory we use different types of memory like magnetic tape, optical disk, hard disk, SSD. Nowadays SSD are coming. So all the these memory actually developed by the different materials or different technology. So speed is also dependent on that how the these devices are developed actually manufactured.
Okay, so that's a fastest because they
Huh.
say it's material.
Yeah,
Okay, thank you.
and we are not calculating speed or anything here in the
Okay,
course. Okay.
thank you.
Hmm. Yes, Sai Swarup.
Good evening, sir.
Good evening.
Sir, as in lecture 3, we saw that the smaller the memory size, the faster will the computations. But I didn't understand the term which is there called gates.
Hmm.
Means if the computation is faster, there will be smaller gates. So what is that?
Gates is also a how this actually operations, this addition, subtractions, these operations are performing by the digital this circuits actually. Okay,
So
actually our computer is actually an electronic device. So how these operations are performing by the electronic circuits. So the gates are actually very smallest part of the electronic device that is actually performed some operation on the this electric signals, which we are generally saying that binary number 0 and 1. 0 means low voltage and 1 means high voltage. So everything actually
Logic gates, sir,
logic gates is also a electronic.
and or these.
Yes,
yes,
correct.
sir.
So you, if you are talking about logic gates, so gates is also gates is a, actually electronic circuits. Okay, so actually which takes the input. So like if I just draw the diagram, so gates is so different types gate we use like AND gate, not gate, and OR gate. So suppose you will later learn these types of gates. So suppose this is the AND gate, like, okay, and this gates takes two inputs and gives one output. So what inputs are possible for this gates is either 0 or 1. Okay, so we can pass 0 and 0. So 0 means low signal, low signal. And there is some internal circuit inside this, some internal circuit is there, and after some operations it returns one output. So generally there are some truth table used for this gate. So AND gate, so AND gate will return high signal when the both input are high only. Okay, so if we are getting 0 0, so you will get 0. Okay, if we are getting 0 1, still you will get 0. If we are getting 1 0, you will get 0 output. But if both input are 1, so that means output will be 1.
We can learn all of these things in truth table, sir.
There are some actually what value are possible. Suppose I'm just mention this, A is the one input and B is the another input. So and output is like we are assigning the Z. So what are the possible input for this gate? So there are actually we can so there are two value, and we can only pass 0 and 1. So there are only 2 to the power 2, 4 possibility are there to give input. So these possibility are 0 0 0 1 and 1 0 1 1. Okay, so if if we are giving the input in that way, what output this gate is returning? Okay, so the property of AND gate is AND gate is always provide the one AND gate provide the one if both input are 1, otherwise 0. Okay, so
Sir,
0 0 0 and 1, this is the property of AND gate.
sir, basically we can think 0 as false and 1 as true. So
No,
that
no, no,
and
no, false and no. Actually, everything is in our electronic circuit and electronic device. Everything is a voltage.
yes, sir. But
This is low and this is high.
in
Sorry,
coding, sir,
one is
when
high.
we do code, we use AND operator. So if both the condition are true, then we'll get the answer true. Both the conditions satisfy.
That is different things. Yeah, concepts are similar. Okay, but
I'm just talking about that AND thing means both
huh,
have to be
no.
true.
You mentioned that what is AND gates. Okay, so gates is different things. Gates is a circuits actually which is used in the electronics devices on the lower levels in
Okay,
the
the
So,
working of
sir, it's
inside the processor actually. You can
yeah,
assume that inside the processor.
the working in the code is different respect of this that
Here this is the gates and the concepts are same which you are talking about, that are the operators actually,
yeah,
for
yeah,
the operators for the coding. So that AND operator and OR operator and NOT operator,
yeah,
the properties and the concepts are same. Similarly so what where we use this actually AND, okay, to check the conditions and
yeah,
to check the expression, what expression is
yes, sir.
returning actually. Okay, so there is, for example, this is the one condition and we are using one sign. So in C, generally in C language we use
yeah,
this sign for the AND. Okay, and another condition is C2. Condition means when we are comparing the numbers, when we are checking it is greater than or less than, these are the conditions. Okay, so here C1 and C2. So if we are using AND, that means this condition should be returned true and this should also be returned true, then overall will consider as a true. If any condition is returning false, then overall will consider as a false. So this is the similar things of the gate which I mentioned that. So you can assume that if we are assuming t equal to 1 and false equal to 0, so this is the similar things. If both are 1, then overall will be 1. If any condition is 0, then overall will become 0. 0 means false.
yeah. We can just take our idea, but
Uh,
the working of gates are different. If
yeah,
we see the
gates are different. Yeah. Yes, yes,
physics
yes.
perspective, we they
Huh.
usually draw that in 12th class we used to study that I don't remember, but
Yes,
the
sir. In
working that electron
semiconductor chapter.
Yes,
semiconductor.
yes,
Yeah,
yes.
thank you.
Yeah,
We
so that
use
actually gates are used actually in the hardware. Actually, how our processor is actually working. Okay, so processor, you will learn all these things in the later course of the electronics. So how our gates is actually works. So some internal circuit is designed for the gate. So so according to this concept, that circuit is works actually. Okay, so so this is the truth table for the AND gate. If any, so the definition is, if both inputs are high, then output will be high for the gates. Okay, otherwise output will be zero. And
Okay, sir.
for the or gates, or concept, if any input, so suppose A, B and Z, so if we are using or, okay, or symbol, so same four possibility are there: 0 1 1 0 and 1 1. Okay, but the definition of the or gate is, if any input is high, output will be high. Okay, so that means if any input is high, so here you can see that here one input is high, output is high. Here one input is high, output is high. Here both input is high, then output will be high. But if both input are low, then output will be low.
So
Okay.
it's different in different cases.
Hmm. So this is the property of OR gate. So similar for the our coding concept when we use the OR things. Okay, so here this is the condition 1 and this is the condition 2. So that means what would be the output of overall? So for overall output, if any condition is any condition C1 or C2, any condition is true, then output will be true. Okay, if both conditions are false, then output will false. So this is the similar things. If this is true, output will be true. Okay, if only this is true, the output will be true. If both are true, output will be true. If both are false, then output will be false. Okay, so concepts are same, but gates is different things, and how these actually things are performed by the processor. So that is the basic concept of the AND or all these things. So processor, so because of that we said that arithmetic and logical unit. So these gates are comes under logical things. So where we can compare the elements, we can perform these logical operations on the input. And arithmetic operations are different, so this subtraction, addition, this type of operations. So gates you will learn in the digital electronics course, maybe in the foundation even, I'm not sure which
Yes,
course.
sir. In digital system and logic.
Yes, you will learn all these things in details.
Okay,
Okay,
sir. Okay.
so yeah, and other things, all these operators things we'll discuss in the big three.
Yes, sir. Yes.
Okay, in the detail, because in from big three onwards, the main programming components will introduce, and we will start the coding also, and you will also get the programming assignment in the assignments. So where we will learn all these type of operators and how we use these operators. There are some very important things also which we will learn.
Sure, sir.
Okay. Okay, so this is the thing. Okay, any other? Yeah, Raj.
Good evening, sir.
Yeah, Raj. Good evening.
My question is regarding with the memory modules, cache memory as well as the registers. My understanding is both are used for storing the data as well as instructions, frequently used. Is it correct,
Yes.
or
Yeah,
what is
correct.
the slight change between this?
No, no, correct. Our registers is actually stored instruction as well as the data, both. And memory things is actually a storage device which stores all the things. Okay,
Okay.
registers are actually just read some data from the memory which are actually currently executing.
They are just a temporary storage.
Yeah, temporary storage. We can see that
Means after
registers are.
some time, the data which is in the particular register will be just
Huh. So what
gone,
happens
and new
actually?
data will be came
Yes.
because
So I'm just explaining you here. So memory is actually this is the RAM first things. Okay, RAM, and there is one higher level is secondary memory. Okay, so this is secondary memory. This is main memory, M. Okay, and there is one layer comes like a cache memory, and then comes registers. Okay, so registers are separate like so this it depends on the architecture, what architecture we are using, and how many processors are there. So this depends on the hardware. Okay, suppose we are using these 6 registers, and registers name are R1, R2, R3, R4, R5, R6. Okay, and so among all these registers, so some registers are specific for the important so another things that are actually called as a program counter. Okay, so suppose there is one program counter. This is also registers, but this program counter is actually stored which instruction will execute next. Okay, so so actually suppose we are writing some code. Okay, we are writing some code in the C, so we use generally editor. Okay, any editor, we can use VS Code, or we can use any C tools where we are writing code. Okay, so that code is actually stored in our hard disk when we are writing the code. Okay, so where one file is created, and this file can be with the name of like C extension or .txt extension. So we are writing some code here, and our code is actually a collection of instructions. Okay, so maybe in our code 100 instructions are there. Okay, when we run, and other things are also running in our there are lots of data in our stored in our hard disk or secondary memory. Okay, so other things are also stored in our hard disk, but we are currently writing some things, and this is also currently stored in our hard disk. But when we run this code, so only this part, okay, only this part will comes in our main memory. Okay, so this code will come in our main memory, and there are like 100 instructions are there in, of this code when we have run this code. Okay, so after that, all the 100 instruction will not run at a time. Okay, so instruction will execute one by one. So suppose we are so our program is executing now. First instruction will execute first. Okay, so if first instruction is executing, and maybe we are performing some a plus b like this. Okay, so we are performing s equal to a plus b in the first instruction, like. Okay, so that means there are some operation. Okay, so this is the operation, this is the operands which contains the value uh, in the memory, and this is also a assignment operator. So this instruction information will move, first it will move to the cache. Okay, and then it will move to the our registers. Actually, this program counter will contain what operation we are performing, so what instruction we have, and the required value which are stored in A and B will stored in our registers, like, so that A value will store here, B value is stored here. Okay, and then processor will take this registers value and perform the operation addition, and it will return some sum on the another temporary registers, and that registers value will be assigned to the this S value, like this. Okay, so now this first instruction is complete, so that part will be complete, and next instruction will come into the register, so all will be clear, like this.
But here there is no instruction saved in registers, sir, correct?
No, if instruction is executed, then that means completed. So registers, yeah, this is one program counter.
Okay.
This is also a registers, but the purpose of this program counter is to store the next instruction which will execute by the current
The data which is in the register after means the operation is done, that data will come in cache,
No, that data will not come into cache. That will
or it will
yeah. So
permanently raise.
suppose in our program we are using s in the upcoming next instruction. Okay, so that means that will remain in the registers. Okay, so this is just an example. If first instruction is so on remaining instruction are not depend on the first instruction, that are actually separate. So that means that part will be complete and data will be removed from the registers. The next instruction will come that execute. So these registers are actually storing the temporary value which is required to execute the current instruction. Okay, and after that that data is removed, and that all these registers are become free, and that free for the execute to the next instruction.
So if there will be more number of registers to the program, or the sum which we are operating will be more faster, or just the same speed?
No, then this is
Does it
depends on
depend
the.
upon the number of register, the speed of that particular program or the
Yes,
instruction?
till some level we can increase the register. Otherwise, the communication head will increase. Okay, so actually the processor. So this is just a basic idea of the processor. Otherwise, our latest processor are using some specific number which are sufficient to execute this. So at a time, one instruction is executing. Okay, so for that instruction, we need these number of registers. These are enough actually. Okay, so if any, so there is no need to store lots of data in the register set, because one instruction is executing at the one time. So if anything is required, that data will fetch from the main memory of, or any instruction or any data which are frequently asked by the processor. Okay, which are repeatedly asked by the processor, and so that data is actually stored in the cache. So in the next cycle, if that data is again required, then first this processor, there is one control unit. That control unit check that that data is available in the cache or not. Okay, if that data is available from the in the cache, then that the processor will directly fetch the data from cache, not from the main memory.
So, please, can you just repeat that? What data is in the cache? Just please
Cache
can you?
data means if any instruction or any data which we are some operation is performing, if
Yeah,
anything which are repeatedly coming in the processors,
yeah.
if any instruction or any data which are repeatedly coming in the processor, so that data is actually stored in the cache memory. So the next time when we used when the processor want to fetch again that data, so first that check in the cache memory, if that data is available in the cache, so it will fetch from the cache directly. Okay.
Repeated data means that
Repeated means frequently asked, which are coming frequently again and again.
no, just like that we are doing a plus b. If the
Hmm.
values of a and b are repeating,
Hmm. So
that
some basic example we can say that suppose we are performing some loop, okay,
yeah,
and loop, and inside the loop we are performing some similar operations. So like s equal to a plus, or we are incrementing the value of s equal to s plus 1. Okay,
okay,
and we are performing this loop 100 times.
okay,
Okay, so that means this operation will perform 100 times again
okay.
and again. So in that case, after
Sir, so the
algorithm,
loop counter does that.
loop counter, this I'm just giving some example, that is not the actual things. uh,
Loop counter to just help to repeat that code if, means
The
we have
set
to
of
not write that
instructions.
repeatedly, that particular code.
yeah, so but the processor is actually executing some instruction. Okay, so this is the instruction which are executing by the processor. So every time the processor is executing what is the value of s, and then from the main memory, and then storing into the registers, so same things. Once again the this instruction is complete, then it will move to the cache memory. Okay, so there are some algorithm used by the operating system actually, that actually determine that which if after some repeating of the data or instruction which are actually coming into the processor, so that actually stored into the cache memory for some time. Okay, so every time processor first check into the cache memory, if data is required data is available in the cache memory, so that data is directly fetched from the cache memory. So in this process the processor actually saves some time, because this store load data and store data, that operation takes some time. So if we are performing this store and load operation with the main memory, it will take more time compared to the cache memory.
So sir, that it's I'm asking on just a small scale that suppose I'm taking Chrome or just YouTube, on that app info we see a cache same.
Yeah,
So
similar thing. So when you
that is
open,
the data which is repeated on that particular app, Chrome or YouTube.
that is actually cookies or these type of things, and cache is also there in the chromes. So suppose if you open any website first time, so
Yeah.
it will take some more time. Okay, but
Yeah. Yeah.
after that, if you are continue opening the same website, so
Yeah, it will
some
be
some
in
yeah,
lesser time.
some
Yeah.
common data will store in the cache. So only anything is changed on the website, that data will be loaded in the next time. The remaining data will directly come from the cache, so the next time that website will open quickly.
Oh, that's why if we just clean all the cache of
Hmm.
that Chrome, everything, just every new site we
Yeah,
visit,
so
that
that
will.
concept is also used in this Chrome where you are searching something. So this actually increase the speed. So same things concept are used inside the processor also. Okay, if
Okay,
any data which are repeatedly required, okay, and which are repeatedly coming in the processor for the execution, so that data is actually temporarily stored inside the cache, and next time it will directly fetch from the cache.
sir,
Not
is
Okay,
from
sir.
this all kinds of memories are physically connected by wires and gates?
yes, fires.
Gates also.
Gates are the another things. Gates are not the communication device. Okay, gates are the some operational device. Okay, gates
Sir,
are the
in
circuit actually.
lecture, professor tell us that more the memory we required more gates and physical wires.
Because of that, na, for the operation actually, if we are performing some operation and we are using lots of registers here, so some if we are performing operations, so we need more circuits actually, which we generally call gates. And there are many things actually, adder, subtractor, all the circuits are actually created inside the processors. So that these things have to increase. And inside the memory things, so some actually uh, okay, so this RAM, and this is also created by the semiconductor device. So how this data is actually they are storing. Okay, so
I
data is
think
also
I think gates are in just CPU and or registers
uh, not the
inside them, and these registers are connected through wires.
all these devices are connected through the wires. Okay, but how the actual data is stored inside the register, so that is also some circuits which we can say that some gate or all this combination of things that actually stores the data, because we are storing this 0 and 1 in the these memory rams and register and cache, all this. So how these are storing actually, so there are some circuits which are holding some high and low voltage for some time. Okay, so there are some circuits inside these memories also, so that are actually storing the data.
Gates are the means the very smallest value of the CPU,
Smallest circuits of the
smallest component of circuit.
component, or yeah, you can say component.
Sir,
Hmm.
sir,
Yes, Prithvi.
sir, while you are explaining the cache memory and the registers, once the some data is being coming out of the CPU and it will be reaching the register, when it goes to the RAM, which means the main
Yeah,
memory,
RAM, yeah.
it will be confirmingly crossing the cache and they will be going to main memory, sir.
Yes.
Yes, sir.
So cache is just for the this way, cache to memories, cache to processor side, not the processor to cache. Okay,
Okay, sir.
because
Yes, sir.
data is or instruction are coming from this main memory to processor. So in this way, we are storing this. We are using this cache.
Yes, sir. Sir, and the cache memory is located inside the CPU or out of the CPU, sir?
Yeah,
Which
so
means,
this is also some processor is actually include this case within their circuits, and sometimes this is there is a separate component for this case.
okay, sir.
Okay,
Thank you,
so this
sir.
is not a fixed things. So some another structure is different structure are there actually.
Yes, sir.
Okay,
Thank you, sir.
Sir, Mike,
yeah,
all
Rajesh.
the answers are given clearly, but just I am concluding.
Mhm.
Whatever the cache as well as registers, both are help us to save data as well as instructions. Fine.
Mhm.
the
Yes.
frequently required data or instructions can be captured from the cache memory, right?
Yes, actually, that is stored for some time. For okay, so for the temporary, that is stored for some times inside the cache.
Okay, so the frequently requested means the processor request will go to the cache only, not to that registers, you mean to say.
Uh, Frequently means if any instruction and any data which are actually repeatedly executing by the processor. So that instruction and data stores for some time in the cache memory, because there is a big chance so that data will requested again. So at that time, processor will directly fetch that data from the cache. So it will save some time for the from the for this communication. Okay.
Okay, okay.
So that increase the processing time speed of the processor actually.
Okay, thank you.
Okay, so because of that, this all type of memory comes in the picture. Otherwise, all the data can be fetched from the secondary memory, okay, by the processor. But the speed of the secondary memory is very low compared to the this mediator memory, RAM and cache. Okay, so this in that ways, which actually any operation and any program which are currently executing, the required data first comes under the RAM main memory. Okay, and what instruction and what process, small part of the process actually executing right now by the processor, that parts comes inside the registers and executes.
Understood, sir. Thank you.
Yeah,
Sir, as am I audible, sir?
yeah, because go ahead.
Sir, as we are just talking about the CPU component, so I think I can ask the question related to ALU.
Yeah.
As you know, sir, ALU is the most crucial component, help us to do arithmetic operation on that the
Yeah.
data which we give.
Yes.
So, sir, if let's suppose there's an arithmetic operation X and that particular uh, if there is an overflow means the data means I mean,
Mm.
arithmetic operation which I'm doing exceeds the limit or there's an particular limits of bits stored in that
Mhm.
CPU. If it exists, so how that ALU
Handle
controls that
this.
overflow.
Okay. So what ALU you are doing actually, ALU are performing on the operation on the binary numbers 0101 like this. Okay.
Hmm.
So all the inputs are coming in the binary form 0101. So at a time it is performing any addition operation between binary this subtraction operation. So any operation if it is performing addition, so this addition is also performing by the binary operations. Okay, it is not taking the directly value like if we are passing 1 lakh or 2 lakh value this type.
Sir, these ALU are
Hmm.
getting those binary numbers.
Yeah, binary
Uh,
numbers or we can say that low and high voltage of the
Simply the
yes, sir.
registers after storing the data in register gives to the ALU. Then ALU
yes.
performs by logic that operation.
Yeah, so
So
registers are also stored actually at the fixed length of the number. So suppose if the size of the register is 32-bit, okay, so every register will only store 32 bits data, and ALU and this processor will perform the operation on this 30-bit data binary number.
so
We cannot give directly 64 or 84 if registers are size is 32.
so there is a different working because I'm not able to catch. Is there a different working of that handling that overflow of ALU? Because maybe if the data is large, so because as I do code in if of
So
any simple
overflow things
mathematics,
is
if I put
different.
large numbers,
Sir, I
so
think that overflow is controlled by control unit.
Yeah, I think so. Otherwise, if we are storing large value which cannot be stored in some specific memory size, that you will get the overflow things. Okay, suppose we are assigning like this integer variable. We are assigning integer variable. So some specific size of memory allocated for integer. If we are passing the big value, then memory size is small. That value will not store and give some error. This type of
okay.
things. Okay,
sir.
so that actually there are lots of things inside the computer. Some part is operating system is also there. Actually, that manage all the things. How the this processor are coming to the processor. Sorry, how the all the operations are coming into RAM and how all the scheduling is happening, because there are many operations which are performing concurrently. So how all these things concurrent operations are performing by the processor, all these things actually managed by the operating systems. Okay, so operating system is also a basically a manager of the computer. Okay, so that actually manage the memory, that actually manage the process, that actually manage all the uh, this everything, file
Okay, sir. I
management.
understood.
Okay,
Yeah.
all the things, but this operating system is actually separate area to learn.
Means
Okay,
operating system is hardly responsible of doing the managing the system of the
yeah,
computer.
everything in the inside what things is happening inside the computer, everything is managed by the OS.
Okay, sir.
Okay, that OS is also a software that manage other application or other softwares.
Manages or just it tells that particular instruction that this instruction have to be happen at first and this have to
This
be
the
done at
managing things.
second.
This all the hardware resource allocations, memory management, and scheduling. All these things managed by the operating systems. Okay, so
Okay, sir.
all the algorithms are designed how it will manage all the things actually. So operating system is actually a different course to learn, and it is also not a single
Uh, Sir, but sir,
chapter.
the program counter controls the set of instructions.
Not control, it stores the.
Program counters are, such basically sees I think that the instruction of the steps in that
Sir,
particular
it just
instruction are
guides
going
what to
right.
do next.
There is one control unit. Okay, so in the CPU, actually there are three parts. One is control unit (CU), and there is one ALU, and next is this registers. This is the main part actually. CU is the main part which actually controls the communication and this all the things. Okay, but inside the register there is one program counter PC, and that actually store the next instruction that will execute after the current executing instruction.
Okay,
Okay,
sir.
so but and control unit this decide where from the next instruction will come into the PC. All the things are managed controlled by the CU. Okay, this pass the address, which address is required to fetch from the memory. Okay, so inside the memory every location actually identified by some address. Okay, so some address is actually passed to the memory, and from that
Sir, some
location that
address decoders.
decoder is also there. uh, yeah, so some actually address is passed, then some decoding thing is also happened during the process, and that from that location data is actually fetched from the memory. Okay, so you will, I think, in week 2, if you have watched the videos and things, so some assembly language things are coming in the picture now, if anyone have seen the videos. Okay, so
I
there is
think in week 3 we'll introduce to operating system at just a
no
glimpse
no
that.
no 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 no, we are not learning operating system, and operating system not a small things to learn. This is separate course to learn. Actually, there are very vague lots of content to learn.
No, no,
Okay, so
just
that will not cover.
that how the booting and bootstrapping, that before that just a small glimpse of operating system.
Actually, because of that, I'm saying that there are lots of things you have to understand before to understand all these basic things. Otherwise, the questions will comes in your mind, because this is the C programming course. If you want to learn how the operating system works, you have to learn operating system course. Okay, so here we are learning C programming course. So what are the basic things is required to understand to interact with the computer? Because of that, these things are introduced.
Okay, sir.
Okay, so if you want to learn another thing, so you have to pick the other course. Okay, and just wait for some time. So later the things will introduce Sola one computer network, then communication and digital electronics. All are the actually the basic levels of the this computer. Okay, so later
Sir,
you will
is
understand
a
all the things.
program counter is also a type of register or a just
Yeah, this is also a register. This is also a memory. Okay, it is storing something that means it is a memory.
okay.
Okay, yeah. Okay, so yeah, Manish.
Good evening, sir.
Good evening, Manish. Yeah, go ahead.
Sir, in the question number 7, compute the absolute value of an integer. Can you please explain question number 7 and what is absolute value?
From which week, which assignment?
Graded assignment.
Week.
Week 1.
Okay.
Yeah, this.
Absolute value of a in. Okay. So absolute value means the positive value.
Okay, sir.
Okay. If we are giving negative value, that should be converted into a positive value.
Okay, sir. Thank you.
Okay. So that means if we are giving any value, final output should become in the positive. If you are giving -3, output should be 3. Okay. So this is the meaning of absolute.
Okay, sir.
Okay. Yeah, Alkesh. Okay. Path Maze.
Good evening, sir.
Yeah, good evening.
Sir, I have problem in question number 10 of week 1 graded assignment.
Yeah, what is the problem?
Sir, unable to do.
Okay. Okay, so I'm just giving some hint to solve. Otherwise, we have saw some question related to this in the previous session. Just one second. So how you can start to solve this type of question? Okay. So here one calculation is
Excuse me, sir.
yes.
Sir, sorry, sir, for my mistake. It's not number 10, it's number 7. Sorry, sir.
Okay. Then I think seventh question we have discussed in the previous session. Seven, this one.
Yes, sir. Question number 7. Uh, sorry, sir. Question number 8. Question number 8.
This
Really
one.
sorry, sir. I'm
I
really
think.
sorry.
Can you just watch the Friday session?
Okay, sir.
Okay, we have discussed this question in on the Friday, and I think also in Saturday.
So, sir, we can ask a graded assignment question also in the live. I suppose that it is of
No,
practice.
no. You cannot discuss, but yeah, basic idea we have discussed. We have not discussed the answer.
Okay, you can just tell that you should
Yeah,
start from here.
yeah. We have discussed how you will process to solve this question. How you will just start. How you can
We
do.
can just ask about the practice assignment that the
Yes,
whole
yes.
question that
Hmm.
practice assignment.
So
Okay.
in the previous session, I have just discussed how you can solve this question.
And then after the deadline of graded
Then you can
assignment is over,
discuss.
then we can ask.
Yeah, you can
Okay,
ask him.
okay, sir.
Okay. So just was the Friday or Saturday session. Okay, we have discussed. I think 2 times this
Okay, sir.
similar question. Okay, and
Thank you,
this
sir.
and this and also the next one, ninth one.
Okay, sir.
Okay, and yep. Next is Prathmesh. Okay, Prikhar Srivastav. You have done. Okay, Sneha.
So, computational equivalency, what does it mean?
Computational equivalence.
Yes, sir.
Uh, where this term is used?
So, practice assignment, 15th question.
Okay. And week 1?
Yes, sir.
Okay. I think definition is also given. No, you can two processor are considered computationally equivalent. That means the power is computational power is actually equivalent. If any task is done by any processor, and another processor can also done the same things. So that means the both are the computationally equivalent. Both have the same computational power. Okay. If any processor is able to solve any specific task, another is also be able to solve the same task. So that means both are the similar computational equivalent.
So in this question, we have to tell that which computer is more powerful, or
No, similar powerful.
so we have to search about
Yeah, you
these
have to just
devices.
yeah, you have to search, explore something. Okay,
For
this is
example,
not discuss anywhere. This is just explore to explore things. So what is the purpose of these processor? So these are actually basically Arduino. This is the electronics related things.
third one is also a processor.
All are processor.
Okay.
Okay. So this is just explore by the explore all the processor by the name and check what is the computational things they can perform. Okay.
Yes, sir.
Sir,
Scientific computing is related to that scientific that calculator or something else.
Yeah, scientific computation
Because
means the
in
similar
our
things.
tablets or in our modern phones,
Uh,
there's a option scientific calculator.
yes,
There we
yes, yes.
got
Correct, correct,
sin
correct.
x, cos x. The
Yeah,
same thing is
correct.
this.
Yeah, correct.
Sir, we have also in qualifier exam,
Yes.
we have scientific calculator there also.
Oh, okay. Yeah, yeah.
sir,
Yeah, Prithvi.
sir, could you please explain me in the graded assignment of week 1, the eighth question, the basic idea alone, sir?
Yeah, we have discussed. I think we on Friday and Saturday both session.
It will be in the online, sir, YouTube.
Yeah, YouTube you can watch. We have
Yes, sir.
discussed
Thank you.
8th and 9th both person.
Okay, sir. I will refer to this. Thank you, sir.
Okay. Yeah. Okay. So actually, these type of questions. So first thing, these memory model questions. Okay. So why this is introduced in the assignments actually? These questions are introduced because to understand the flow of the execution. Okay, because computer is just a electronics device. Okay, computer cannot do anything without our instructions. Okay, what task you want to perform by the computer, you have to tell the sequence of instruction to the computer, then computer will perform the things. Otherwise computer can't do anything without any given instruction. Okay, so you should know how computers execute the things, how the processor actually execute the things by this given sequence, and finally you are getting the required output or not. Okay, some instruction set is given 1 to 8. Okay, so we will start executing from top to bottom side. Okay, so one by one we will perform each instructions, and then we will check finally we are getting the required output or not. So to understand this flow of execution, we are giving this type of question from the first week. Okay, so this is not a practical things, and this is not verify on any editor or any tools. This is just to perform some dry run. Okay, how you can just apply the dry run on the given instruction, just pass some value and check what things are happening during the process and what you are getting finally. Okay, so this is the basic of the programming. You should know how you can write the steps for the before writing the code. Okay, so there is this memory model type of questions in week 2 you will also see. So this is the steps are more closer to the processor actually. Okay, so how the processor is reading the value from the memory and storing to the registers, and how it is performing some operation and then loading the data again into the memory. Okay, so this is very closer to the processor. Now the next level will are discussed in the big 2. So if you see the big 2 assignments, you will once again find this is similar type of question, but the some syntax is different. Okay, so then like question number 9, okay, question number 10. Okay, here some instruction is given. Okay, we are talking about what instruction is, we are processor are actually storing, how what instruction program counter is actually storing. So actually this instruction is called as a assembly language instruction. Okay, so assembly language is closer to the machine level language. Okay, because computer, this processor is actually understand only binary things, 010101, that is called the machine code. And the one higher level is the assembly language, okay, which actually processor understands some what is the meaning of this operation. So what if we are writing move, if we are writing this loop, if we are writing ADD. So these are some instruction which are predefined for the assembly language, which is understood by the lower level of the machine. And when we pass this instruction, then this is also converted into a binary language, 010101.
Sir,
This
so
is,
all the letters and numbers are converted into binary codes.
yeah, in the final stage all things are converted into a binary things. Okay, and all these operations, so we are writing add, okay, that there is some binary code for this. There's some one assigned binary code for this, so that code is actually used for the processor. So everything is identified some binary things. So in big 2 this is discussed how the actually numbers and how things are represented by the inside the computer actually. So all this number system. Okay, so this is called a assembly language, but same things. You don't need to learn this all this instruction, move, add, all these things. We are giving the comment in the questions also. Okay, so if you are writing this MOVR110, so what is the meaning of this? We have mentioned in the comment. Okay, you can understand the meaning of this operation by reading the comment. Okay, so to and but the sequence is the similar. Okay, just follow the sequence and you will get the required output according to the problem. So this is also a similar sequence of steps in assembly language. Okay, and this is also a basic of the programming. Before writing the code, you should know the flow of execution. Okay, sequence, how the computer are actually performing, executing the instructions, and we are getting the output, required output. Okay, so this is the assembly language things. So week 2 you will find this type of questions, some in the practice and some in the graded also. And from week 3 onwards the main programming question will come. And before writing the programming code, you should clearly understand that how the flow of execution happening when we are writing some sequence of instruction. Okay, so because of that, today actually I wanted to discuss some basic of the programming. So how we actually gives the instruction, how we actually write the instruction to solve any programming problems. Okay, so first thing, okay, 1 second. So every problem actually, okay, what finally we have to do, we will get some problem, okay, and we will write the instruction for to solve that problem. Okay, and every problem is actually contains some input. Okay, so there is one input stage, input, we will give some input to the problem, and there is one part in between, and finally we will get the output. Okay, so this is the cycle of the program actually. Every time we will get some input, and we need to return some output according to the problem statement, what problems we are receiving. Okay, so this is the part actually which we generally call the logic. Okay, this is the part we call logic, and this is also called transform input to output, input to required output. Okay, output. How we can transform the input to the output according to the problem statement. So this is the main part where we need to write the steps. Okay, so and we have to decide what logic we can use to solve the problems, and we have to write the steps to apply this logic. So you should know, for every problems you will always get some input and you have to return or print some output. Okay, and in between you have to write some logic, and for writing the logic there are 2 or 3 types for the things you have to do before writing the code actually. So what you can do, there are some terms actually used. First is algorithm. Okay, algorithm. Second is flowchart, and third is pseudocode. What is this? Okay, so I think you are aware of these terms. Anyone can tell me what is algorithms?
Certain steps or of the code.
Yes. So we are writing a sequence of steps. Okay, in our general life. Okay, so we generally use these algorithms for to do anything. If we suppose if you are going to give the qualifier exam, okay, and your center is not in your city and center is in the another city, so definitely you will make a plan 1 or 2 days before how you will go to the that city to give your qualifier exams. Okay, so you will make what time you will wake up, and then how you will prepare yourself, and then what is your transport where you need to pick to move the one city to another city. And you also just take some backup plan also if you miss some transport. Suppose if you are planning to go with the train, and then by chance if you miss the train, then you will pick the bus or anything else. So that means some sequence of steps you created in your minds, and you perform your task according to your predefined steps. Okay, so this algorithm things is actually uh, used in our real life also for the everything. Okay, so same things here for interaction, the interact to the computer. So computer don't understand our language actually. Okay, so we are understand this our human language, but computer don't know the our language. We cannot instruct the computer by in our human language. So we so these different types of programming language is designed that actually computer understand, and that language is also understand by the human. So that language is actually called the high level language, which is actually very similar to our English language. Okay, so we can easily understand the things by reading the syntax, and we can also understand that syntax, and computer is also understand. Okay, some process is also defined, predefined, so that actually instruction is converted to into a assembly language, then assembly language to machine level language, then executed by the processor.
Sir,
So
algorithm and code are similar thing, or
no,
algorithm contains code? Yeah, both are different thing.
no, all these three are not the code. I'm not talking
No,
about
no,
the
I'm
code
talking
anything.
algorithm and code. These both are different.
Yeah, both are different. Code is actually the actual code where we will use the syntax which are given by the programming language. Okay, we cannot violate any rules or syntax rule in the coding. But what is algorithm? Algorithm is just a steps which we generally created. You can write this step in the normal English, your language. You can write in English, or you can write in any language which you know. Okay, just write the sequence of steps what you will do during the to solve the problem.
Algorithm is written in a high level language.
No. You can write algorithm in any. So as I said that algorithm is just a sequence of steps. Okay, and these steps we cannot give directly to the computer. This is just a steps which we can understand. And
For
after
us
that, for us,
to,
after
to understand that code.
yeah, after so after writing these steps, we can easily convert these steps into a code. Okay, so this is just a steps which we can write on paper and pen, and we can understand that this sequence of steps will provide the correct output if we
So
follow
in
the
dry run we use we
yes.
write algorithm.
Yes, so we can apply the dry run on the algorithms and check that we are getting correct output or not. If we are
Then we
getting
write code with
if we are
particular
getting
logic and proper instructions.
yes, if we are getting correct output, then we can convert that steps into a code where we will use the syntax which we programming language are providing. Okay, so this is the first thing. Algorithm is a sequence of steps. It can be written in any language. You can write in any language, or which are actually you can understand easily. Okay, this is just a sequence of steps, like step 1, what is the step 1, okay, step 2, like you can write this. And when you apply the dry run, you will follow this sequence, step 1 to last step. Okay, and what is flowchart? Flowchart is also represent the algorithms, but in the graphical form. Okay, this is the graphical representation where we can also understand the flow of execution. Okay, so flowchart is a graphical representation of the algorithm. And pseudocode, what is pseudocode actually? Pseudocode is also this is closer to the code. Okay, here we can say that this is a rough code. You are writing a code, writing a algorithms in the code form, but you can just you can skip some rules and these things.
We
Okay,
can
there's
in pseudocode the sign semicolon we can skip these.
Yeah, these you can skip. Okay,
But
you
an
no
algorithm
need
we have to write those.
in algorithm you can write in the English language. Okay, just write the English in the sentence. Okay, flowchart you can represent in the graphical form, that is steps. Pseudocode you can write the rough code where you can skip some rule. Okay, this is not strict actually, but it is similar to the actual code.
How can we write steps in the flowchart? Means graph
Uh-huh.
can be the output that we are giving certain input, and the input, because
So this
input
is
we are
actually
getting output which is in graph.
all these three are the steps which are required for us to understand the program or understand the steps. Okay, not for the computer. We will not give as it is to the computer all the things. Okay, we will finally write the code, but before writing the code, we should practice to write algorithm or flowchart or pseudocode, anything. Okay, then once you are your flowchart and algorithm are running correctly on the input and giving the correct output, and you are satisfied that your logic is okay, then you just convert this algorithm or flowchart into a code.
Flowchart
Okay.
will type of tell us that this will be the output.
Yes.
Means we are writing algorithm and then writing that I'll get this output in this type of flowchart.
Yeah.
Then we can
So
reject from it.
now I'm giving some example. Okay. So suppose
Sir.
Yes, Prithvi.
Sir, yes, sir. Sir, these three steps are done before a program for a better understand of a human, for of the program by the human, sir.
Yes. So this should be the good practice. If you are new to the programming, this is the good
Okay,
practice. Before writing the code, just write the algorithms on the paper and pen, and
Okay,
then
sir.
apply the dry run. Just pass the input on your algorithms and check your algorithms steps are giving the correct output or not. Okay, then write the code. So after doing this practice on some problems, maybe initial 10 problem, 20 problems, 30 problems. So after that, this pseudo code and this algorithms, this will you will develop these things in your mind. Okay, these things will be
Yes.
developed in your mind, and then you can directly think the steps and you can directly write the code without
Yes, sir.
writing the algorithms on the paper and pen. But initially, you should write these things on the paper and pen. Okay.
Yes, sir.
For the
Sir,
good,
while writing the pseudocode,
yes,
we will be using the representation used in the same program but
Yeah.
in a unorganized rough way, sir.
Yeah, rough way. Okay.
Yes, sir.
Initially, just so initially maybe you don't know what is the exact syntax. Okay, so just write the syntax which you know. So maybe you will get some error initially, but after rectifying these errors, sometimes you will also learn the syntax. So in the programming course, I am just telling you that you cannot learn the syntax by reading the content.
Yes,
You
sir.
can learn the syntax by writing the content.
Yes, sir.
Okay, so if you don't know what is the syntax for loop, so you cannot learn by reading the syntax. Maybe after sometimes you will forget, but after writing for loop syntax by maybe 10 or 20 times, you cannot forget the syntax. Okay, so
Yes, sir.
this is totally a hands-on course. Just practice on the editor once the coding is started. Just practice on the editor. Because of that, we will give programming assignment to you, practice assignment, programming assignment, then mock, timely mock. And also we are planning to we are just creating some videos where uh, we will just tell you how to solve the programming problem. So we are creating some videos also. That content will be released very soon. Okay.
Yes, sir.
Yeah. Okay, so this is the initial things which you can start on paper and pen initially. Okay, once you are comfortable, then these things will automatically started created in your mind. Okay, what is the steps? So I am just giving one example of the basic example. Okay, and we want to write a program which will return the sum of two input number. Okay, sum of two input number. So what step we can write? Okay, so according to our process, so what our process is, there is one input stays, there is one output stays, in between logical part or calculation part, we can say that. Okay, one second. Sorry. So because suppose if we want to solve, if not we want to, actually we want to write a code to for the computer, so computer can solve, computer can take two input and return the sum of that two inputs. Okay, this is the basic one. Okay, so how we can write the steps? So step you have already see in the week 1 and week 2 in the modeling form and the assembly language form. But in the algorithm forms, you can just write like step 1. Okay, so I'm writing first algorithms. Okay, and this is not a fixed, and we are not following any strict rule here to writing the algorithms. You can write in your language anything, okay, which you can understand. Okay, so just read. Okay, so I'm writing read value of a. Okay, step 2, read value of b, or we can write both statement in one steps, read value of a and b. Okay, so this is for our understanding. After that, step number 3, we are taking some variable name. Okay, so this is actually called variable name, where we store the actual data, and where the actual data is stored in memory. Okay, suppose this is a memory block. We just occupy two memory blocks, and actual memory address is actually very difficult to remember. Okay, so this is in the hexadecimal form or binary form like this. Okay, but we give just one name which we can understand. So you can just give this name like first value. Okay, and here you can give like second value.
So this is algorithm or pseudocode?
This is algorithm. Okay, I'm writing the steps which we will follow, and we will check we are getting the correct output or not. Okay, and step 3, so this is the input part we have written, where we are reading the input. Okay, and we are taking some input, and now we will calculate. Okay, so calculate sum of first value and second value. Okay, and how you can calculate? You can simply write that one thing, you will just add all these variable values. So first value plus second value value. Okay, and store this result into a another variable, like you can give the name sum. Okay, sum. So sum equal to first value. So now this is the calculation part. Okay, this is the input, and this is the logic or calculation part, and now the output part. Okay, so output part to display the, like step 4, display the output, display the value of sum. You can write like value of sum. Okay, and end. Step 5, you can just write that step 5 end. Okay, so this is just a sequence of steps which we have written in own language. So now just follow. If you are passing any 10 value here and 20 value here, okay, 2 value. So 10 value is passing to first value variable. Okay, and first value is associated with some memory. Okay, where we give the name of memory in our language. So first, this is just generally called the variable. Okay, you will learn all these things in week 3. Second value. Okay, now these two memory location we occupied, and we are storing 10 here and 20 here. Okay, now finally we can just calculate these things. So 10 plus 20 and 30 will store inside the sum. So sum is also occupied some memory, and 30 will store inside the sum. Okay, this is the memory representation which we are generally we have already seen in M0, M1, M2 like this. Okay, but during the coding we will directly use these terms. We will give some variable name, and internally some memory will allocate for this name. So now this is the sequence of steps. Okay, and we consider this is an algorithm. Now you pass any random value just to check the dry run. So 10 and 20. Okay, and 10 and 20 you are getting 30, and 30 are storing into sum, and we are displaying sum in the output. Okay, so this is the output part, and so you can see that we are following the correct sequence of steps. So any value, if you are passing here 50 and 50, you will get 100 in the sum. So this is the algorithms, and how we can write the flow chart. Okay, so similar for this. So similar, the some box is actually you can just use. Okay, so this is the start. Yes.
These steps, if we write in that previously we write these steps in the form of transistors and memory,
Yeah,
resistors and memory. Sorry.
Yes, yes.
That is also an algorithm.
Yeah, that is also an algorithm, but that will be difficult to understand when you just read later. Okay, this is just to give some idea how the communication happens during the computation. Okay, these are also
both are the forms of algorithm. One is
yes.
more comfortable to read for human, and other is much more
correct.
take time.
Okay, so so at the end of time you will write the code. Okay, coding. So you should write the algorithm which you can understand easily. After reading the steps, you can easily understand. Okay, that will be difficult. Otherwise, if you write every time algorithm in the memory model forms, that will be difficult to understand to you also. Okay.
Okay, sir.
I think Vikas. Yeah, Vikas, go ahead.
No, sir, I have asked. Sorry.
Okay. Just... Yeah, someone. Yeah, Prikhar.
So whenever we need to find the minimum number of steps, like you have written, suppose if we taken A plus B plus C. So sir, how many operands at a time we can take? Like suppose A plus B we can do in one step, and after that, suppose we have stored in that memory, and that memory plus C.
During the coding, you can make the expression. Okay, so there is no problem.
Suppose we have suppose we need to find the minimum steps.
Minimum
steps? Like we can do A plus B plus C in single step, or we need to do in two by taking 2 operands at a time.
No. In the coding, you can write in the single step also.
Okay, but actually in the assignment, we need to find the minimum number of steps.
Yeah, because here actually we have some restriction of the registers and memory things. So because of that, we can use only these limited number of registers. But during the coding, you can create any number of variables where the memory will be assigned to you.
But like theoretically, we can take any number of operands at a time,
Yes,
right?
yes. During writing the algorithms before the coding, you can assume any number of variables.
Yeah, so suppose like
according
we
to the
have to find a
problems.
biquadratic to the power 4 number, so we can actually write it b into b into b into b at a one step
Yes,
only, right?
yes. Yeah, you
Okay.
can write.
Thank you.
Okay. So coding
But
is actually provide the
as he is
flexibility for
talking
this.
about steps, so does algorithm depends on step, means if steps are more, the algorithm will
Yeah,
take time.
that things is different things. That efficiency and optimization, that is different things. Once you learn the coding,
I'm
then
just asking code because I
that
have
is
some idea to write code because in the qualifier exam we have learned that how to write code, simple codes.
no.
So
Actually, in qualifier, in this complete course, we are not learning that part. So we are not asking that you should write the minimum number of steps, or your code should contain the minimum number of steps. That things we are not asking in this course. That
I'm
is
just
actually
asking generally that because I've studied that at larger level that if there's minimum step, the algorithm depends upon step. That if your steps are, your code or your algorithm is good, so it will be, if it will be more faster.
yes. That is correct things. So that actually, okay, I'll just give some idea. Okay, actually, any problems can be solved by different logic. Okay, so there is no fixed solution for any problems. Okay, so any problems can be solved by two different codes, two different approach. Okay, so in that
Okay.
way, which approach is good, which approach is fast? So there are some parameter we generally use to compare the code or compare the algorithms. So that is actually one advanced level of the programming that comes after the this first programming course.
That is for means this depends upon when we are talking about larger numbers of line
Yes.
of
So
code.
suppose I'm just giving one example. Okay. Uh, if anyone is writing, suppose this is the block where we are writing some syntax. Okay. Anyone is writing a logic, and that logic is actually performing 100 instruction to execute to solve any specific problem A. Okay. And another one is writing it very good logic, and he's solving that problem into only 5 steps. Okay, and practically you can assume that processor is execute instruction one by one, and it will take some time. It is very less, but still it will take some time. Okay, the execution time, suppose I am just assuming that it is taking 1 nanosecond. Okay, one instruction execution time is taking like 1 nanosecond. Okay, now total instruction are 100, so 100 nanosecond is required to compute this operation. And another person is written the code which is using some another logic and solving the problem in 5 steps. So here processor will execute only 5 steps and will take 5 nanosecond. So definitely this is faster.
Okay, sir. Okay.
Okay, so that is different things that is actually we will not discuss during this course. Which course is better, which code is better, which is not better, which is faster. This things is we will not, we will focus only to writing the code and create the logic only in
No,
during
I
this
was
course.
just asking that I am writing code that if I write any, I take any input of number, the code will tell me its palindrome, the sum of its digits, reverse. If all these three, four things come together, then it takes 2 3 seconds. And if I just write in just 100 to 50 words, it will take just in a 1 second, because every second that if I am doing in C line, it will tell that this is the time. So from this I thought that there would be an connection between steps and algorithm.
Yeah, definitely this is the practical things. If anything is happening, it will definitely, it will take some time. If we are performing lots of instruction, it will take larger time. If we are performing less instruction, it will take less time. So that is the good things, but after this course.
Okay, sir.
Okay, so
Okay, thank you, sir.
yeah, optimum things or efficient code, that we will discuss after this course. So this is the separate course, is actually we called as a data structure and algorithm course. Okay, so here actually we will only focus to writing the code and learn the syntax and writing creating the logic. So okay, now this is the second things, flowchart. So flowchart, so this is the steps you have to read each and every line to understand the things. Flowchart, you can just quickly see the diagram and you can follow the things and quickly understand. Okay, I will give some another example where you can easily understand by the flow. So now flow means we are starting from the start keyword, and there are some identification of box. So if we are just drawing this type of box, so this is for the input. Okay, input, what we are input first value and second value, first value and second value. Okay, next step is calculate the, this is the rectangle box. Okay, so this is the rectangular, we are calculating sum equal to first value plus second value. Okay, and third step is output. So we will write print or display like this. Okay, so print sum and end. This is the sequence. Okay, so here we are not writing lots of statements to understand, we are writing the main points. So here we are just reading some input. Okay, input first value and second value, then we are performing calculation logic.
Sir, if the flowchart is very clean and neat, so why do we need algorithm to do that?
Yeah, this is up to you, what you want to follow. I'm not saying that just create all the things every time. Okay, if you are
so in
okay
these
with the
all
flowchart,
those three choices we have to make one.
yes.
Okay, sir.
Okay, you can create the flowchart if you are find this is good. Okay, so this is one example, and so I'm not discussing pseudocode because we have not discussed anything about the syntax of the C. Okay, but at the time of when the program assignment will come from the big three, we will discuss. Okay, so this is the algorithm and this is flowchart. Suppose a different problem. Okay, so we want to find out the number is even or odd. Okay, any input number is given and we want to just print out that that number is even, and we are just assuming that this number is n. Okay, n can be anything. So we are taking this input, any input for the n, and we are printing the output that this input number is even or odd. Okay, so steps we can write like this. Step 1, read value of n. Okay, step 2, then here we will check the condition. We have to apply the condition. Okay, what condition we can apply? If okay, yeah, and we can just check the reminder. So this is the reminder sign which we used in the language. So this is the reminder and 2. If this value is equal to 1, okay, so this condition we are writing here. If we are dividing n by 2 and reminder is coming to 1, so that means we will go to step number, like we can write this, go to step 3. Okay, so step 3 is print or display, like display n is odd. Okay, and we are also writing otherwise go to step 4. Okay, and now step 4 is display n is even. Okay, and step 5 is n. Okay, this is, so this is the logic here. This part is the logic. Actually we are just dividing by 2. If reminder is coming 1, then we are just saying that this number is odd. If otherwise means if reminder is not equal to 1, so only 2 reminders are possible, 0 and 1. Okay, if 1 is not coming, that means 0 is coming. So in that case, we will move to the step number 4 directly from here. Okay, so if you directly move step number 4 and display n is even. Okay, so this is the algorithm. Now the flow chart, we will start the start, and we will just read the input, and now here we will just mark the control statement. Okay, conditional statement. If n2 equal to 1. Okay, so now one side we can assume that this condition is true. Okay, and one side we can assume that this condition is false. Okay, now flow is, if condition is false, then print this is condition, okay, even. Okay, and if condition is true, then print odd. Okay, and later we will come to end like this. Okay, now if we show this flow chart to you, you can easily understand the steps. Just this is the starting things. Take the input, what is the value of input, and after getting the input, just divide that input by 2 and checking that if the remainder is equal to 1. So this is the condition to check. If this condition is true, that means number is odd. Okay, so this means if condition is true, then we will move, the flow will move to the right side. Okay, and if this condition is false, then flow of execution will move to the left side. Okay, and during this, then we will reach to the end. So this is the flow of execution. So now pass any value. So like we are passing 10 to in this input. Now check 10 divided by 2. What is the remainder is coming? 0. So 0 is not equal to 1. That means false. So just move this side, even number. Okay, so print even. Just pass 7. So 7 is divided by 2 equal to 1. Yes. So when you are dividing 7 by 2, you are getting one remainder, which is equal to 1. So that means this condition is true. So now move this side and print odd. Okay. So in that way, then you can identify that the logic is okay. Then you can convert this flowchart into code. So this is the good practice. If before writing the code, before solving any problem, just try to write the algorithms steps or flowchart for your logic. So first step is input, and final step is output, and mediate step is just the logic or calculations to get the output. Okay, so this is the things you should understand before the writing the code. And how you can practice more on this before week 3. So there is one tool, if maybe you know or don't know, I don't know, that Scratch. If anyone have listened about this, this is very basic tool to understand the programming. And this is also a one things when you can create some animations, and you can also understand the programming things. Okay, so I'm just relating these things with the programming. What is actually programming? So programming, so like the C programming language we are talking about. So every programming language contains some set of instructions, and set of rules. Okay, that we generally call syntax and semantics. Syntax is actually what instructions we can write. Okay, some meaning is also associated with all the syntax, and according to that, according to our program, we can use that syntax to write the code. Okay, we cannot write anything. Okay, so we can just follow the syntax which is providing by the language, and then we can write the code for the problem. Okay, so now just relate this this Scratch. So this is one tool to create animations. You can download from the Google directly this Scratch tool, and you can just start to understanding the programming. So here you can see one space. Okay, so I'm just mentioning you. So this is the one space. Okay, this white space is actually a space where we will write the instructions. Okay, this is the space where we can affect the code, our sequence of instructions. Okay, and some characters and objects are predefined. We can directly use these characters to create some animations, and we can also see the program, basic program we can also see here by using these steps. And on the left side, okay, so here this all the circle point, actually these are some different types of group of instructions. So motion, look, sound, events, all these different types of instruction set. And in the this line, okay, all these are actually instructions we can use. Okay, all these are instruction set. We can use this instruction to create a program. Okay, create some things on these tools. Okay, now how we can use this? I'm just giving one basic demo. So I'm just picking one object. Okay, this is one moving object, and I'm reducing the size 40. Okay, or this is very small, like 60. Okay, now this is the background. One background, we can also change the background, and we can pick any object. So there are lots of objects we have in this tool. And how we can just create some animation for this. Initially this is not doing anything. Okay, there is no step happen is here, and here our is goal to just move this person onto the right side. Okay, right side. So how we can make this move? By writing the instructions. Okay, this is just there's no instruction, nothing is happening on this screen. Okay, now there is one instruction which is comes under motion. Okay, so motion. Now we can just drag this and we can pick here, move 10. Okay, now that means this is a one instruction. This will move this object to the right on 10 steps. Now you can change the value also. You can just give 20 steps. Okay, now when you click on this, you can just figure out that this is this object is moved to the right little bit. Okay, if you feel that this is very small movement, you can just change the value, so like 50. Okay, when you click on this instruction, you can see this object is moving 50 steps onto the right. Okay, now this is the one thing, when we are just clicking on one instruction, that instruction is executing and one movement is happening for the 50 steps. So that value we can pass how much instruction, how much steps you want to move. Okay, now we want to move this. So suppose we have 10 steps at a time, and we want to move this object onto the right 100 steps. So there is one thing, we can write 100 this instruction 10 times. Okay, one, two, three, 4, 5, 6, 7, 8, 9, and 10. Okay, so these are single steps, and we have written 10 times this. So after adding all the value 10, 10, 10, you are getting 100. So that means when we click on this instruction, all 10 instruction one will be executed one by one, and you will get the movement for the 100 steps. So you can see the movement is happening in the 100 steps. Okay, so this is the one things you can write a sequence of steps. But suppose if we want to move this into a 500 steps, or we don't want to change the value. Okay, so do we need to write this instruction more 40 times? This is not the correct way. So there is that tools is actually provide the another syntax which is actually loop. Okay, and that it comes under the control. So repeat. Now this is one. Okay, now I'm remove some steps. Once again. Okay, now you have already seen looping in some more modeling this data model memory model questions, loop things. Okay, now this is the one is repeat. Okay, so 10 times 10, every time we are moving 10 steps. So this is the repeat instruction. This is similar to the loop things. Okay, and we are performing this inside blue color move steps 10 times. So that means if we click on this repeat instruction, so this move steps will perform 10 times because we have given 10 value here. If we pass 50 value here, so that means the inner instruction will execute 50 times. So 50 into 10, 500 movement will steps movement will happen. You can see the object is going to the outside. Okay. So this is the loop things. Okay, so similarly you can use all this similar type of the instruction which is actually used inside the coding language. So this is the loop, and if else also you can use. Okay, so this is one if else condition. If any condition is true, then this should be happen, which is just discussed for the even and odd number. Okay, so suppose if we are giving some value, uh, one value set a, and we're taking condition, and then we're taking movement. Okay, steps, else nothing. So here what I'm taking, we are taking one a value and we are setting this value like 10. Okay, and we are passing this a value here in this condition. A. So this is one condition. If a is greater than 50, then it will move 10 steps, or we change this value 10, sorry, 100. If a is greater than 50, then it will move 100 steps. If this condition is not true, then nothing is happening. Okay, we are not doing anything. In else part, we have not written any instructions. So you can see when we click on this, nothing, there's no movement happening. Okay, because the value of a is 10, which is not greater than 50. But when we change this value to 60, now the condition statement will become true. So now this a is greater than 50, then this instruction move instruction will perform, and you can see the movement. Okay, so this is the control statement if else condition. Okay, if the condition is true, then this happen, otherwise another instruction is happen. Okay, so this is the if else things. So similar so this is the animation things. You can just do explore the things, and you can also create some good animations by during the learning of these things. Otherwise, if we want to write the code for the which I just discussed, okay, for the sum of two number, we can also test here. So I'm taking some value. Okay, a, b, and sum. Okay, I'm taking three locations, a, b, and sum. Now I am just writing the sequence of steps. Okay, set a equal to some things and set b equal to some things. Okay, initially both are 0, and now set sum for, okay, so sum, I'm changing this here, sum to a plus b. Okay, so for a plus b, I am just reading this operation and writing here. Okay, so yeah, so this is the sequence. Okay, okay, I need to writing the variable here, so a and b. Okay, so which I just discussed to write the code for the sum of two input numbers, so a and b. So I am just giving some value like 20 for the a and 30 for the b. Okay, and next instruction is sum to a plus b. Now when we click on this, you can see the output on the right screen. Okay, so a value is 20, b is 30, sum is 50. Okay, you are getting correct sum answer. So this is the sequence of steps we have to write to the computer, and then computer will execute one by one. Okay, so this is the one program. Another program is which we have written to check the number is even and odd. Okay, so similar things we can write the different sequence. So suppose we are taking a and we want to check this a is even and odd. Okay, so we can write the sequence of instruction for this. So just check the things. If else, you can use if else here. Control statement block. If, okay, after this, if what condition we need to check? Okay, so this reminder things, I think reminder will not be calculated, so operation is not there for this. So operation is only assigned plus, minus, multiplication, division. So we cannot do this thing. Otherwise we can compare which number is max. Okay, we are giving a and b two numbers, and we can write the program for which number is maximum. So just pass the another value b, and another, make another variable like max. Okay, and sorry, so like max to 0. Okay, now you can write the if else condition, control statement. Okay, now you can just give the condition, control statement, operations, and logical operations. Okay, so we are passing this condition if a is greater than b. Okay, so here we are passing if a is greater than b. Okay, a is greater than b. Okay, now what we need to do, we just set if this condition is true, then max equal to a. Okay, so max equal to a, otherwise max equal to that max equal to b. Okay, so this is a sequence of steps where you can see that we can give input for a and b, and we are just checking that which number is max. Okay, so now suppose if I am giving this a equal to 20 and b equal to 10, so what value is coming inside the max? So we will run this. You can see that max equal to 20. Okay, so I am removing this sum from the output. Yeah, so you can see that a equal to 20, b equal to 10, max is coming 20. If I am assigning b 100, so when we run this, you can see max is coming 100. Okay, so this is the sequence of steps you can write and check what output is coming in the output variable. So in that way, you can understand the basic syntax of the coding, and similar things is actually used in every programming language. So this is if else condition, and loop statement is also there. All the control statement, this repeat, forever, if else, repeat until, all this similar type of syntax is actually created for the programming language, but the syntax is different, but the concept is same. Okay, so before starting the third week, you can do some practice on this tools, a scratch tool, and to write the sequence of steps by creating the animation, as well as by creating some sequence to solve the basic problems. Okay, so you will get some basic idea what is happening inside these instructions. Okay, in the fun way, you can create the animation also. Yes,
Sir, could you please teach me the doubts in the week 2 topic, sir?
week 2 topic.
Yes, sir.
Okay, so what's your doubt?
Sir, in that in the third lecture, especially while representing the real valued numbers in form of zeros and ones, real valued numbers.
The number system.
What is the method that is? What is the method that is scaling factor, sir?
Which factor? Sorry, caring.
Scaling factor. Scaling factor. That if you get a number, it's dividing by 2 to the power 8.
Okay, I will tell some
That
different method. If you are not able to find out that method is comfortable with you, I will tell you different method also. Okay, so before that topics, if anyone have any doubt in these things, algorithms, flowchart, and these things, so okay, so just do these things before week 3. Okay, also learn the week 2 topic, as well as just do these fun things to understand the programming steps. Okay, and from week 3 onwards, basically the main syntax will come. So you will just figure out you will face some difficulty to understand this if else, for loop, while loop. So you can do some fun things on this tool to understand all the things. Okay, yeah. So yeah, number system. I'm not going in detail of the week 2 contents because week 2 contents will discuss on this Friday and Saturday sessions. Okay, in details that's all number system, but for the binary system, how you can calculate the binary for any decimal number things, I'm just telling the logic for this. Okay, so suppose if you given any decimal number, so in the human things we generally use this decimal number. So suppose we have like 26. Okay, this is a decimal number, we are assuming that, where the base is 10. Okay, base is 10 means we can write any number with the help of 0 to 9. We have 10 different types of numbers to create any number. Okay, so how we can convert this number into a binary number 0 and 1 forms, where this binary representation is actually understood by the computer. So how we can convert this 26 into a binary form where the base is 2. Base is 2 means any number can be represented by using this two number 0 and 1. We can use only these two different number to make any number. Okay, so how we can convert this? So there is one division method. Actually in lecture I think sir is discussed with the different methods where you can put some 1 and 0 in the different power value, but I am just telling you one easy method, division method, where you can convert this decimal to a binary number. So what is the division method is? Just divide this decimal number by 2. Okay, because we are converting this decimal number into a binary number base 2. So divide this decimal number by 2 and check what remainder is coming every time in every steps. Okay, so when you are dividing 26, what remainder is coming? 0. And what that divisor value is coming? 13. Correct? Okay, in the first step, when we are dividing 26 by 2, remainder is 0 and the divided value is this quotient value is 13. Now once again we will repeat this process. We will repeat this process until we will get less than 2 value. Okay, so now once again divide by 2, remainder is coming 1 and quotient value is 6. Once again divide with this 0 and 3. Okay, and divide this, the value is coming 1 and now here is also 1. Okay, now this is the next value, so 2 1 and here 1 is coming, now 0. Okay, so we will repeat this process until we will get 0. Now after getting these things, just read the value from bottom to up, this remainder value. Okay, just read this remainder value. What you are getting? 11010. So this is a binary value of 26. Okay, and in the form of which sir explained, you can also write this. So this is the form. So you can simply write this. So 0 into 2 to the power 0 plus 1 into 2 to the power 1 plus 0 into 2 to the power 0, 2 plus 1 into 2 to the power 3 plus 1 into 2 to the power 4. Okay, so now you can just calculate all the value, you will get 26. So here 0 plus this is 2 to the power 1 and 2 plus this is 2 to the power 2 4 into 0 0 plus 8 plus 16. Okay, so 16 plus 8 24 plus 2 26. Okay, you are getting 26. Okay, so this is the number system. You can convert any decimal number into a binary number, and if binary number is given, then you can convert that binary number into a decimal number by this formula, this logic. Okay, so just start this 2 to the power 0 1 2 3 4 in this form and just multiply by this sequence. Okay, and calculate the value. You're getting decimal. Okay, so this is the division method. You can also follow this. This is the easy, I think, calculate the binary number for any decimal number. Okay.
So,
Yes.
why the power of 2 is only used here for binary codes?
Because we have only two possible value. Okay, in binary number we can use only two numbers to create any numbers. Okay, 0 and 1. Because of that we are using 2. If we want to convert the similar, okay, so another number system is also there. Suppose 26, this is a decimal number, and we want to convert this into an octal number. Octal number where the base is possible 8 and the value are possible 0, 1, 2, 3, 4, 5, 6 and 7. So only this. Okay, total 8 value are possible to create any number. Okay, decimal number, why we are saying decimal? Because here we have a set of 10 numbers, okay, 0 to 9 to create any number. Octal, we can use this 8 digit to create any number. Binary, we can use only 2 digit, 0 or 1. Okay, so based on this factor, we are using this base. And to calculate this octal number, so what process we will use? So 26 divided by 8. Okay, now what value we are, reminder we are getting? 2. Okay, and 3 here. Now next is 8 and 3 and 0 here. Okay, so that means if we move here 32. Okay, that means 26 which we are representing in the decimal form. Okay, that is equivalent to 32 in the octal form. Okay, so this 32 is the similar of 26, but here it is in the octal number system 8. Now if you calculate the value of this into a decimal number, so this is the octal things. Now here if you want to calculate this octal to decimal, then perform the same things here, but now this time we will use 8 to the power 0. Okay, so 8 to the power 0 and plus 8 to the power 1. Okay, and what value will come here? 2. Okay, so 2 into, and second value will come here 3 into. Okay, now calculate that. 8 to the power 0 is 1. 1 into 2, 2, plus 8 to the power 1 is 8. 8 into 3, 24, and we are getting 26. Okay, so in that way, if we are calculating binary, so divide by 2 to convert into binary, and to convert binary number into decimal, just multiply in that way. Use 2 to the power.
Okay, sir.
Okay, so the next session, Friday or Saturday, that things we'll discuss in detail. Number systems conversion. Okay, so you can ask this queries. Okay, I hope this is clear. Some basic idea, it is clear. Okay, so I hope that's it for today. So any query from anyone?
No, sir.
Okay.
No, sir.
Okay. Then if there's no query, then you can close the session.
Thank you, sir.
Okay. Thanks, everyone. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay.